Hi, in this video we are going to talk about applications of recursion. Recursion is one of the core topics in programming. Any problem which can be programmed using iteration can also be programmed using recursion. Similarly, a problem which can be programmed using recursion can also be programmed using iteration. They both have same expressive powers. Now the question arises, if we can write equivalent iterative code for every recursive or equivalent recursive code for every iterative, where do we use recursion? Where does the use of recursion come? Here are some examples where we use recursion. First thing is, many standard algorithmic techniques like dynamic programming, backtracking, divide and conquer, they are basically recursive in nature. In dynamic programming, generally the first step is to write a recursive solution. Once we write a recursive solution and we see overlapping subproblems in it, we optimize it using dynamic programming. There are many standard problems which can be solved using dynamic programming like LCS, added distance, and these problems are used a lot in real world life. For example, finding the diff between two files is an application of LCS. And dynamic programming's first step is recursion. We solve problems first using recursion, we see overlapping subproblems, and then we apply memoization or tabulation. Backtracking solutions are inherently recursive in nature. When we are solving a problem like rat in a maze or n-queen problem that we are going to study, these problem solutions are generally inherently recursive in nature. It's very easy to write recursive code than iterative one. Divide and conquer. Divide and conquer algorithms are mostly implemented using recursion. For example, quicksort, merge sort. These are divide and conquer algorithms, and you generally find their recursive implementations in textbooks and most of the other places. Binary search is also divide and conquer, and people many times write recursive binary search. There are many problems which are inherently recursive in nature. It's very easy to write a recursive code for these problems than writing equivalent iterative code. For example, Tower of Hanoi, we have a separate video on this topic. DFS based traversals, DFS of a graph and other DFS based traversals like in-order, pre-order, post-order traversals of tree, and variations of these DFS traversals, this DFS of graph and variations of these traversals are inherently in nature, inherently recursive in nature. If you write an iterative code, that becomes really complex and unreadable. A real-world example of DFS is searching for a file in your computer. Say you are working on Linux system where you have root folder which has subfolders, and these subfolders have their subfolders, and then you have files. So when you're searching for a file, you do something like depth first search traversal. You begin from the root folder, then you recursively search in one of its subfolders, then recursively search in its subfolders. So that's how you recursively search for a file in your computer. Now all these examples that I've written here, they can also be solved using iteration. As I said earlier, iteration and recursion generally have same expressive power. And many times when you have an equivalent iterative code causes less overhead. For example, binary search. If you write recursive binary search, it's going to take big O of log n auxiliary space, but if you write iterative binary search, it's going to take big O of 1 auxiliary space. And one more problem with recursion is function call overhead. But still, recursion is used in implementations because of ease in implementation. For example, if you try and writing iterative quicksort, iterative merge sort, iterative tree traversal, iterative Tower of Hanoi, the code is going to be very complex. However, equivalent recursive code is going to be very simple. Apart from these applications, recursive programming or thinking recursively is a necessary skill for programmers. Many problems, as I said earlier, these programming techniques which are core programming techniques, and there are many problems in these techniques, they require you to think recursively. Think of a solution in a way that if you have solution of a subproblem, how do you use the solution of subproblem to solve the bigger problems. So that's what is recursive thinking. It's very much required. Many times we first write recursive code, then we convert into iterative as we do in dynamic programming. Solving problems using recursion is fun also. We are going to solve many problems in the upcoming videos.